Okay, let's run through some examples from Chapter 5, Form Tolerances. These are problems that are taken from your book, so they're not study guide problems, but they're going to be similar to the study guide problem, so you can kind of adapt what I'm doing here. First problem we're going to look at is problem number 43. It says apply a feature control frame to specify a flatness tolerance for the top surface of the given part. Okay, so we're talking about this surface right here. We have two views. We have a front view and a right side view. And this is the surface that we want to control with a flatness tolerance. The flatness tolerance of 0.006 of an inch. Now, we have a couple ways that we can do this. A flatness tolerance is not going to be specific to the view that we apply the tolerance to. So it's a little bit different than a straightness tolerance. So a flatness tolerance, we could in fact apply it in this view or in this view. Okay, and I'll show you the different ways that we can apply this. Okay, so first of all, using the front view here, we can, and I'm going to work with this this kind of spacing here. Of course, if you're doing your own sketching, you can kind of adjust this, but we could apply the flatness tolerance to the extension line. There we go. All right, 0.006 of an inch flatness applied to the top surface. Remember that there is no datum reference on the right-hand side, so we only have two boxes for form tolerances. Another way that we could do this is to point to the surface and make the same feature control frame. Okay, with an arrow. All right, so 0.06 flatness. We could also point to the extension line. Okay, and we can do both of those things on the all three of these applications on the right-hand side. So over here, we don't have a extension line, but we can always create an extension line over here. Okay, extension lines don't have to be used just for dimensions. We could point to the surface, or we could point to an extension line. All right. So those are the three, I guess, 6 different ways that we could apply a flatness tolerance to the top surface. Okay, let's move on to the next one here. So the next one we're going to look at is problem number 44 in your textbook. Okay, and this one says apply a derived median line straightness. Okay, so let's underline that. Derived median line straightness tolerance of 0.012 of an inch, 0.012 inches diameter on the 563 diameter. Okay, so here's the 563 diameter on this stepped shaft or step pin. And it also wants us to apply another derived median line straightness tolerance of 8 thou on the 785 diameter and show the MMC modifier on both tolerances. Okay, so this last sentence kind of gives it away, but just for a reminder, remember that we can apply a straightness tolerance to a feature or a feature of size, to a non-size feature or a feature of size. In this case, we're applying it, derived median line straightness is applied as to a feature of size. Okay, and the giveaway is this last sentence. You cannot use an MMC modifier. You cannot use a material condition modifier. They do not apply to non-size features, only features of size. Okay, so now for this, so how do we, let's do the first one here. Remember that for a geometric control applied to a feature of size, the feature control frame needs to be associated with the size dimension. So we have a couple of options here. We could hang the feature control frame underneath the dimension. Okay, and here we would have a straightness tolerance with a diameter of 0.012 applied at maximum material condition. Alternately, we could extend the dimension line here and use the same feature control frame. Straightness, diameter 0.012 at maximum material condition. Okay. Notice, by the way, I'm not putting the little double quotes here to signify inches. That's completely not necessary. All right. So there we have the first part. Now the second part says apply a derived median line straightness of 1/8 thou on the 785. So here's the 785. Well, it's going to be the same thing. So we could do either hang it under the 785, or I don't really have room to do that, so I'm just going to do straightness, diameter 0.008 at maximum material condition. All right. So that is problem number 44 done. Okay. So let's move on. Now this set of problems is going to be for the same drawing. So here we have, this is going to be, we're going to look at problems 45, 46, and 47 here. And for all three of these, we're referencing this dimension for a hole. So we have a hole, right, that has a size dimension of diameter 875 minus 0 plus 4 thou. And we have a derived median line straightness. Okay, let's use the correct terminology. We have a derived median line straightness applied to this hole of a diameter of 3,007 inch at maximum material condition. Okay, so let's answer each one of these. Okay, so first, number 45, what is the MMC size of the hole? Well, remember that the MMC size of a hole is going to be its smallest diameter. So the MMC size of the hole, let me use a diameter symbol, is going to be 875, right? Because it's going to be 875 minus 0, all right? So that's number 45. All right. Now, using the given hole specification here, calculate the virtual condition of the hole. Show your calculations. Okay, so we talked about this in the presentation. The virtual condition is equal to, this is a negative feature. So a hole is a negative feature. Okay, a hole is a negative feature. So the virtual condition for a negative feature is going to be the MMC size of the feature minus the tolerance at MMC. Okay, so I usually use, when I'm doing my own calculations, I use a little minus sign here because it's the virtual condition of a negative feature. All right, and that reminds me, minus sign, there we go. So the MMC size is 875. The tolerance at MMC is 3 thou. So the virtual condition of this hole is 875 minus 3, or 872. Diameter 872. Okay? Now finally, it says the given hole specification permits 3 thou derived median line straightness variation at MMC. Okay, that's what that means. Calculate the allowable straightness tolerance for a hole produced at 877 diameter. Show your calculations. Now for this, I could do the calculation just in a single little equation. Okay, but I feel like that hides kind of what's going on. So I'm actually going to create a table to show you how the derived median line straightness tolerance varies as the hole diameter varies. So I'm going to make a little table right here, and I encourage you to do the same thing when you're doing your work here. And this is going to be the hole size, and this is going to be the tolerance. Okay. Now let's run through the ranges of the hole size. We know that the hole size can start at 875, right? And the hole size can also be 876, right? We could also do an 877 hole, right? Because that's within the tolerance range. We can go all the way up to 879, right? 875 plus 4 is 879. So 878 and 879, right? So here's 5 different hole sizes that are acceptable. They're within the range of allowable sizes on this. Now, we already said the tolerance at MMC, this is MMC, the tolerance at MMC is 3 thou. All right. Now, this equals a virtual condition of 872. Right? This minus this equals 872. Well, this is a constant. Remember, this is a constant. So it's going to be 872 here too. What do we need to get to 872? Well, the tolerance then is going to be 0.004. Right? 876 minus 4 is 872. Oh, look, this is a constant, 872. So 877 minus what equals 872? 0.005. 872. 878 minus what equals 872? 0.006. You see how this is going? 3, 4, 5, 6. So what we're basically saying, what we're showing here, is that the tolerance varies according to the produced hole size. Now, you might be wondering why that happens. Well, think about it this way. If you produce a hole at its MMC size, therefore its smallest size, okay, how easy is it going to be to get a pin of size 872 through it? Well, it's going to be pretty difficult, and we're only going to have 3 thou of tolerance, right? But if we have this 872 pin, and we try to get it into an 876 hole, oh, look, we got a little bit more room. So we can accept, we can tolerate a little bit more derived median line variation. So this is saying, hey, your tolerance can grow a little bit if your hole size grows, because it's easier to get a certain size pin into a hole if it's the largest size. This is the LMC size, okay? So what does it say now? It says calculate the allowable straightness tolerance for a hole produced at 877. Well, where's 877? Right there. So the answer is 0.005 derived median line straightness at 0.877 diameter. Okay? All right. So let's do our last one here. Our last set, I should say. And we're going to look at problems 48, 49, and 50. Okay? And it's going to be the same thing. Okay? We have a hole 625 plus 5 minus 0. Minus 1 thou. Derived median line straightness of 5 thou at MMC. All right. Now I'll run through this a little bit quicker because I'm going to apply the same thing. So what is the MMC size of the hole? The MMC size is equal to 625 minus 1 thou, or diameter 624. Okay? Number 49. Using the given hole specifications, calculate the virtual condition of the hole. Show your calculation. All right, so we're still talking about a negative feature, a hole. So the virtual condition for a negative feature is equal to the MMC size minus the tolerance at MMC. So this is equal to 624 minus the tolerance at MMC is right there, 0.005 is equal to 0.619 Okay, so the virtual condition size of this is 619 in diameter. And then finally, the given hole specification permits 5 thou derived median line straightness, at MMC. Calculate the allowable straightness at 629. So again, I'm going to do, like I always do, I like making this little chart. So we'll make the chart and we'll do the hole size here and we'll do the tolerance. And at 624, which is the MMC size, the tolerance is 0.005, right? 624 is the MMC size, and 5 thou is the tolerance at MMC. As we deviate from MMC, so it's going to go up. It's going to go 625, 626, 627. I'm going to run out of room here, so I'll go 628, and then we'll go ... 630. Sorry for running out of room there. The virtual condition is going to remain constant, 0.619. 625 minus what equals 619? Well, it's going to be 0.006, 0.007, 0.008, 0.009, and ... 0.011. All right. All of these are going to have a constant virtual condition. 630 minus, right? 630 minus 0.011 equals 619. All right. And so the question is, what's the tolerance at 629? It was one that I didn't do. So it's going to be right in there. It's going to be the tolerance at diameter 0.629. That's supposed to be an at symbol. Equals 0.010 inches. All right, so that's the answer to 50. Okay, so I have a couple more to do here to finish out my demos. So we'll look at problem number 51 next. Okay, so this says sketch the given part to show the possible surface conditions for the top surface. Show the size tolerance and form tolerances. All right, so I'm going to use a red pen here to kind of help me show this. All right, so the size tolerance for this part ranges from 50 minus 0.03 to 0.5 plus 0.03. So it's going to be, I'm going to exaggerate this, and you should too. I'm going to exaggerate it right there. Okay, so this can range from 0.47, right? 0.5 minus 0.03 to 0.53. Okay, so that's the size range for this part. Now I have a flatness tolerance of 7 thou. And so the flatness tolerance, I'll write that in red. The flatness tolerance is going to, the tolerance zone is a pair of parallel plates that are separated by, in this case, 7 thou. So they are not oriented. They just cannot exceed the boundary, okay, the upper and lower boundaries. So this is 0.007 inches. And the surface, now what color do I have here? The surface, I have a green. The surface, the actual surface, can exist within this 47 to 53 range, but its flatness profile cannot exceed the 7 thou. So that right there would be the answer. Okay. Now, of course, there's a lot of other answers that are equally valid. That's just one of them. I want you to note, though, remember, The flatness tolerance, and in fact any of the form tolerances, straightness, flatness, circularity, cylindricity, do not have, they're not oriented towards any feature. That is to say, they don't have to be parallel to the bottom surface or parallel to these two. So it's free to float at an angle, provided it doesn't go above or below the max and min sizes. Okay. Now the last example is going to be kind of similar here. It says sketch one possible effect of the given tolerance. Now here we have a derived median line straightness tolerance on a pin of 5 thou at MMC. Show the virtual condition boundary and show the derived median line straightness. Now the virtual condition boundary is kind of like the envelope of perfect form, kind of, but it's the virtual condition envelope. All right. So that I will show this. Actually, you know what? I think I'm going to kind of sketch this separately. So here's my okay. The diameter of this is going to be the virtual condition size. So the virtual condition size, remember this is a positive feature, so the virtual condition for a positive feature is going to be 944, right? 934 plus 10, plus the tolerance at MMC, 0.005, equals 0.949. All right, so 0.949. So that's the virtual condition boundary, so to speak. The pin is going to exist within that, okay? And we have a straightness tolerance of 5 thou. So let's imagine what that could be. We could have a pin that is going to be bent like that, okay? And I'm going to go like that. And then my derived median line straightness is going to be 0.005 at MMC. Okay, so that basically shows how much it could bend at MMC. Okay, if we make the, in this case, if we make the pin at its at any other size, and just so we're clear, we haven't done a positive feature yet, but let's go ahead and make that table, right? Because we haven't done this in the example, so we might as well. This is going to be the pin size, pin diameter, and this is going to be the tolerance, right? So the pin diameter will start at its MMC size, which would be 944, right? The tolerance at its MMC size is 5 thou, 0.005. That yields a virtual condition of 949, right? 944 plus 5 is 940. Now remember, this is constant, right? So if I produce a pin at the next size down, right? Let's say 940. Wait, I'm going the wrong way. 934. Well, I don't want to go 34. Let's go 43, right? Because we're going, this is the MMC size, so we go down in size, 943. To get to 944, it's going to be 0.006, right? 943 plus 6 is 0.949. 942. We're gonna go all the way. We could go all the way to 924. I don't think I'm going to be able to get that because that's a that's a lot of numbers on this. So I'll do a couple of these. 942 to get to 949. 007. So again, 942 plus 7 equals 949. This is the constant right there. Okay. 941.008. let's do the last one, dot, dot, dot. The last one is going to be 924. 924. So what's the tolerance at 924? Well, look, 949 minus 924 is 5.0.025. So the tolerance, the largest tolerance that we could have on this straightness tolerance is found if we produce the pin at its smallest acceptable size, which would be diameter 924. In that case, we have an acceptable and allowable straightness tolerance of 0.025 inches. Okay? All right. So I hope that helps with working some of these examples in chapter 5, form tolerances. Like I said, the study guide problems are going to be slightly different, but the same idea. All right. So let me know if you have any questions about this. Thanks. Bye.